All right, here we go. We're back again, and we have properties of equality. Well, these four are properties of equality. This is, I suppose it's a property of equality because it's a way to, it's a way to simplify expressions and still have an equivalent expression, something that represents equally. I'm going to dump a lot on you right now. I want you to follow along. This is, I'm going to be showing you how I use and apply these properties to solve for a variable. All right, so I'd like to figure out what this unknown number is. I picked X today. I like smiley face. Smiley face is in here right now, but leave a message after the video. So right here, we're adding 4 to some number to get me to 100. Okay, I'm going to pick a property strategically. Okay, because I could use any of them. I could I could add 4 to both of these expressions and it would stay equal as long as I did 4 to both expressions. That would make this x plus 8 and that would make this 104. But I really want to pay attention to those inverse operations, okay? And I'm going to write it here, inverse operations. So which operation, which of these 4 operations, adding, subtracting, multiplying, dividing, is going to help me isolate or get that variable all by itself, okay? And so the key here is we're adding this 4. So we're going to subtract this 4. So I'm going to subtract 4 from both of these expressions. If you would like to draw your little fence or line, that's fine. 4 minus 4 is 0, so that leaves me with x by itself. I don't write the 0. We just understand that that's 0, and x plus 0 is just x. 100 minus 4 is 96. So that means the variable that I was solving for represents 96. So this is without any application. So I'm just trying to emphasize these properties and how they work. Excuse me. So for this, x is 96. That's my solution, okay? Right here, again, I saw this was adding, so I used the inverse operation, subtraction. So that's the opposite. Here I'm subtracting, so I'm going to use the inverse operation. So we're going to add 6, okay? This again becomes 0, so that's just x. That x stays right there, no problem. 100 plus 6 is 106. So right here my solution is going to be x is equal to 106. All right? Down here, when a number and a letter are right there next to each other, that implies multiplication, okay? So we are going to do the inverse operation. We're going to divide. So I'm going to divide. You may not have known this. I hope you know it, but you may not have known this, but this bar right here, it looks like a fraction bar. It always represents dividing a top number by the bottom number, okay? It does represent the operation of division. 4 divided by 4 is just 1. And just like before, I don't write that 1 in front of the term or in front of the variable. It's understood that it's there. If it were not 1, it were 0, then it would just, it wouldn't exist anymore. 100 divided by 4, that's 25. Okay, so this is my solution here. And you might guess here what I'm going to do. I'm going to use that inverse operation, multiplication, because this is division, and I'm going to multiply by 4. Now, I will use 4 over 1 just to kind of help you understand. If you know how to simplify your fractions, you know that these 4s would simplify to be 1, and you would be left with 1 times 1 or divided by 1. All of those multiplying by 1 just leaves the number that you're multiplying by alone, okay? That's the identity property, which should really go up here. Okay, we'll do that another time. Oh, I messed up because, see, I only divided this side by 4. You have to divide both expressions by 4. So we're going to go backwards. We're going to fix that. We're going to divide 20 by 4, and we will get 5. Okay? So these are our answers for one-step equations. Okay? So I'm going to come at you again with how do we go to 2 steps. All right? As a matter of fact, let's go ahead and let's do 2 steps, and then we're going to go into the other ones. All right, so 2-step equations. Ooh. Yeah. All right, here, again, we're looking at these 2. We'll do distributive and combining like terms in the next video, but 2-step equations, okay? before I can even deal with 2x, I have to deal with this term that has no variable, okay? So we're going to take care of the term with no variable. Now that is a positive 9. It doesn't have a sign in front of it, but we understand that that's addition, okay? So, or that's a positive number. So I'm going to use the inverse operation to get rid of it. I'm going to subtract 9 from both expressions, and the expressions are on either side of my equation, or your equal sign. So 9 minus 9, that's 0. So that leaves me with minus 2x. Because of that minus sign, it implies it's negative. So it duals as a subtraction and a negative, okay? You'll get used to that. That is a little bit foreign. 37 minus 9 gives me 28. And now just like the one steps down here, this is multiplication. The inverse would be division. When you divide, you also divide by whatever sign that number is. That number is negative. Subtraction and negative, they're synonyms. So subtraction, so this negative 2 divided by negative 2 is 1. And 28 divided by negative 2 is negative 14. Okay, so x is negative 14. That is my answer. Let's try this one more time. It doesn't matter what order the numbers are in. The goal here is to get that x by itself. I cannot do anything right now to the x divided by 3 because I have this term without a coefficient, or excuse me, without a variable. Inverse operation. So that is a minus 10 or negative 10. Remember, those are synonyms in this, for all intents and purposes right here. All right, so minus 10, I'm going to add 10. I'm just isolating these and dealing with this piece. So add 10 here. So this is 24. And that's x divided by 3. And we're going to use the inverse operation there and multiply it by 3. Okay, so we're going to do times 3 over 1. That simplifies to just 1 and 1x. 24 times 3. Oh my. Whoa. Triangles coming out of nowhere. All right, Bill. Times 3. 24 times 3, 3 over 1 is the same as 3. But 24 times 3, 72. Okay. All right. So give it a go. We have some other problems coming down your way. We have the distributive property coming your way. But really, you're using this to kind of help you practice. Okay? All right. Good luck. I'll see you then.